This is the MATH201 final exam review. So this is mainly about integrals, the last part of this class. I have put together these 19 problems for the review, and I will just work through them, hopefully help you prepare for the test. Before I do the problems, let me just take a couple minutes and do a quick review of integrals. So as we go through this, it'll make sense. If you take any further calculus classes, you're going to do all kinds of integrals. But to start with, there are three integrals that we started with. The first one is the power rule. And that's where your integral is in this form. So this is integral of x to the n with respect to x. We'll call this dx. N is a number. 2, 5, -3, 1/2, 2/3. Now there's one special number it cannot be, but I'm going to talk about that in a minute. For me, the easiest way to integrate this kind of problem is you take whatever your exponent is. Well, first you write your base. You take the original exponent and always add 1 to it. And then in the bottom of a fraction, you take that new exponent, and that's what goes in the bottom. And don't forget, you always have to add the integration constant, which is always plus c. Okay, it's just plus c. Don't forget it. You lose a point on the exam if you forget it. Quick examples. The integral of x to the fourth with respect to x is my base. My exponent is 4. I'm going to add 1 to it, which is 5. Then the 5 goes on the bottom. A few twists. This doesn't quite fit the rule here, except, you know what we can do? If I want to get this x cubed in the top, I can do that by making it x to the -3, and now I can apply this power rule. So once again, here's my exponent. I'm going to add 1 to it. You add 1 to -3, you get -2. And then at the bottom of the fraction, and normally proper etiquette, this would be the normal way you'd probably see it written. One other little twist, occasionally, you may have some kind of radical you need to integrate. The key to integrating these is, like in most of math, to do anything at all, you need to get rid of this radical, and I'm going to convert it into a rational exponent. Hopefully you all remember that square root of x means the same thing as x to the 1/2. Here's my original exponent. I'm going to add 1 to it. 1 plus 1/2 is 3/2. And then in the bottom, I put my new exponent. Hopefully you all remember how to handle these complex fractions. One rule of thumb is, whatever the fraction is in the bottom, if you flip it, then you can move it to the top, right? So if I flip 3/2, it's 2/3, and it gets moved to the top. See, I forgot the constant right here. And there you go. Now, there's one number that we put in for n, and if n is that number, we cannot use the power rule. So here's the only case where the power rule doesn't work. And actually, let's use the power rule, and you'll see why it doesn't work. I'm going to get this x up in the numerator in the top, so I can rename this x to the minus 1 dx. So if I apply the power rule, I add 1 to this exponent, negative 1 plus 1 is 0, and then what goes in the denominator? 0. But of course, in the world of math, we can never have 0 in the denominator. So if I want to take the integral of this, I cannot do this. There's actually a special rule for just this case. So when you have 1 over a variable or something where your exponent is 1, ends up being natural log, and you have to put these absolute value signs in here. Which sort of makes sense because, you know, remember, integrals are also called antiderivatives. When you take an integral, it's like you're reversing the derivative. Do you remember what's the derivative of natural log? 1 over x. So it makes sense if I take this and then take the antiderivative, go the opposite direction, you end up with natural log. So in summary, here's the first rule we use all the time. The second rule we use occasionally when you have this situation. And then there's one more situation we're going to occasionally face. And that's our old friend, natural exponential function. So if you have e to some exponent, a to the x, the integral of this is, e's are nice because in this case you just simply rewrite the exponential, but then in the bottom you now take the derivative of the exponent. Derivative of a to the x is just a. So as an example, the integral of e to the 2x dx, e to the 2x, take the integral of that exponent, which is just 2. I'm sorry, the derivative of the exponent. If I said integral, I meant derivative. When you do this, you take the derivative of this exponent, it goes here, and you're done. Now, so these are the 3 rules of integration that we basically started with. Now there's a couple little twists. For example, four x cubed dx, integral of 4x cubed. I can use the power rule for x cubed. This coefficient, when it's a number, it just sort of tags along. Matter of fact, sometimes, some people you'll see will write it like this. They move it even outside the integral. It doesn't affect the integration. I go ahead and take my integral, and the 4 tags along, and in this case, this 4 and this 4 would cancel. And lo and behold, So if you had integral of 2 over x dx, this coefficient, you don't necessarily have to move it like this, but just basically it just tags along till you're done. So just to make it very clear, this is what we basically have. So what's the integral of 1 over x? We know it's natural log absolute value of x. The 2 just tags along, and there we go. The other thing that will happen is we'll have multiple terms inside the integral. So how about the integral of 3x squared minus 5x plus 4 square root of x. Take the integral with respect to x. This is also pretty straightforward because what you can do when you have multiple terms, you can break the integral up into 3 separate integrals. You can break this up. Once again, you would probably never write it like this, but just to show you what's going on. In effect, you can make each one of these a separate integral. I'm going to change this to, so in effect, you just take the integral of these one at a time. This would be x squared over 2. This would be x to the 3 halves over 3 halves, and then plus c. And I'm not even going to go any further because that's what I wanted to show you. So that is very basic integration. Now later on, we're going to look at some integrals a little more complicated, and we'll learn something called solving by substitution. But for now, these first problems on the review look a lot like this. So for instance, let's just start in now that we've done our quick review. So the first problem, integral of 2x dx. All right, the 2 is a coefficient. We've got x. We can apply the power rule 2, and then x squared over 2 plus c. You always try and cancel or simplify these as much as possible. Pretty straightforward. Actually, I think we already did this one in our little summary. Integral of square root of x dx. Change that to a rational exponent. Once again, apply the power rule. You add 1 to your exponent, it becomes 3 halves. Then the exponent goes on the bottom. To simplify this complex fraction, move it to the top and flip it. All right, we've done that before. Now, if you ever, what's interesting, if you ever, like on a test, are doing some integrals and you're all done and you have time and you want to check your work, you know what you do? If you take the derivative of your answer, you should get the original integral. So in other words, if I take the derivative of x squared plus c, it's 2x, which is what I started with. If I took the integral, I took the derivative of this. Let me just show you that real quick. So I say my answer is 2/3 x to the 3/2 plus c. I'm going to take the derivative of this. Derivative of x to 3/2. Remember derivative, you bring the exponent. So the 2/3 is here. Bring the exponent down front. You subtract 1. And then the derivative of a constant is 0. Multiply this out. You end up with x to the 1/2, which I can rewrite the square root of x, which is what you started with. So, forgot to mention that, but so on a test, if you're all done and you want to check your work, you go to all your integration problems and you take the derivative of your answer, and you should get the original integral, which confirms that you did it correctly. So back to number 3, I forget how I got off on that. Anyways, 2 times exponential function. The 2 tags along e to the x. Just copy it, take the derivative, which is nothing. There we go. All right, let's keep going. Hopefully you're not finding these too difficult. Number 4 is the integral of 1 over x squared minus 1 over x cubed. So once again, 2 different terms. We can almost, or basically, we just take the integrals separately. Now I've got my variables, my exponential functions are both in the denominator. I need to get them up into the numerator. So I can rewrite this as x to the minus 2 minus x to the minus 3. Now I can take the integrals of each of these separately. So x to the minus 2, if you add 1, you get minus 1, and then minus 1 goes on the bottom. X to the minus 3, you add 1, and you get negative 2, and then negative 2 goes on the bottom. Now if you simplify this and get rid of the negative exponents, so x to the minus 1 is going to go on the bottom. It's a minus here, so basically it's minus 1 over x. Now you notice this negative 2 here, and when you subtract, those cancel, so this becomes plus. And that's what you should see in the answer key. So far, power rule. How about number 5? 1 over 2x plus 2x minus 2x squared. So now I have an integral over 3 terms. So what do? You just basically take the integral of each term separately. Look at this first one. All right, this is that special case. I've just got x in the denominator. I can't use the power rule. I have to use the rule that this turns into a natural log. And these two are pretty straightforward, just power rules. So the 1/2, by rule, the integral of 1 over x is natural log absolute value of x. 2x, the 2's here. X, you add 1, and you put the exponent in the bottom. Minus 2x squared, you add 1. Exponent becomes 3, and the 3 goes in the bottom. And then, of course, you have your... So if we try to simplify this a little bit, 1/2 natural log absolute value of x. This 2 and this 2 cancel. Minus 2/3 x cubed plus c. All right, so far so good. Number 6, this one's a little bit of a trick, sort of. we got x squared plus 3x minus 2 over square root of x. Now we've actually, this is almost just like, we've got this polynomial on the top, and then we've got this square root of x in the bottom. We don't really know how to integrate this, but first of all, let's, just to save time, let's go and switch that to x to the 1/2. And then hopefully you realize I can actually have 3 terms in the top, and here's my denominator. I can break this up into 3 separate fractions. So x squared over x to the 1/2, quotient rule says you end up with 2 minus 1/2. So x to the 3/2. And then 3x over x to the 1/2. And then finally 2 over, although really, just to save time, so what you can do in this case is you can actually break that up into 3 separate terms, and then we can use the power rule. So this first one, you add 1 to the exponent, it's going to be 5/2. So the 5/2 goes in the bottom. Plus 3, x to the 1/2, add 1 here. X to the 3/2 goes in the bottom. Minus 2. So this is x to the negative 1/2. So when you add 1, it's 1/2. So 1/2 in the bottom. Now if I can squeeze this in here. Flip this, move it to the top. 2/5 x to the 5/2. When you flip this, actually the 3 and the 3 are going to cancel out. So you end up with 2 times x to the 3/2. And this one, when you flip it, move it up, you get 2 times 2. And just to make sure I didn't mess up, I have the key here, and that looks correct. All right, let's do a few more of these, because in a minute we're going to discuss a new method to solve some more complicated integrals. But let me go ahead and finish out what I've got a few minutes left. I think you're ready for number 7. Because this one also is pretty, whoops. All right, getting a little more complicated. Here we have x times, in parentheses, 2x plus 1 squared. We don't really have a rule. Now in a few minutes, the next thing we're going to learn about is something called integration by substitution. And this looks like the kind of integral that we would try that on, although you know what? If I tried to do that here, it doesn't work. So I'm really sort of stuck. So sometimes the only thing you can do, if I rewrite this, hopefully you all realize that 2x plus 1 squared is really this. And sometimes you just have to bite the bullet. I'm going to multiply out these 2 binomials. A lot of you guys like to FOIL. And then when I'm done with that, multiply it by x. So if I FOIL, 2x times 2x is 4x squared, 2x times 1, and then 1 times 2x, 1 times 1. Let's sort of skip some steps here. So 4x squared times x, 4x cubed. This 2x and this 2x add together, which is 4x times x. And then this x times 1. So we started here, and now we have 3 terms added together, and we can use the power rule to integrate these. So x to the 4th over 4 plus 4x cubed over 3 plus x squared over 2. Guess those cancel out. You're left with that. And once again, I'm going to check and make sure. And yep, that looks like the correct answer in the key. Looks like one more. Then we'll start a new video, because then we discuss a new method of integration. So number 8, 2 e to the 2x plus 2 over x. Integrate that with respect to x. 2 terms. Here I have an exponential function, natural exponential function. Here, 2 over x. I realize that's going to end up being a log, natural log, when I integrate. So let's just go and do it. So the 2 stays. When you integrate this natural exponential function, you just rewrite it, and then you divide it by the derivative of your exponent. 2, the integral of 1 over x is natural log of x. So by the time you're all done, actually I don't need to do this because these just cancel out. It should be e to the 2x plus 2 natural log, absolute value of x plus c, and that is correct. All right, now we're getting ready for 9, and we're going to stop here now because we're going to explain a new concept, and we'll do that on the next video.